Let's use this idea of quadratic optimization to solve this problem. It says a farmer wants to construct a garden bed from 40 meters of fencing. One side of the garden bed is an existing wall. We need to determine what is the maximum possible area we can make this garden bed. So we start by drawing a diagram. Here, this side here represents the existing wall that's already there. So here I make my rectangular garden bed where these two ends are opposite. I'm going to call them a length of x. Now, given that I already had 40 meters of fencing, this side here must be a length of 40 minus 2x from either side. Now we're trying to work out maximum area. So this is going to be our length and this is going to be our width. So area is equal to length times width. So that's 40 minus 2x times x, which if we wanted to, we could expand out to the equation of negative 2x squared minus 40x. So we've simply used a basic area equation to come up with a quadratic equation. So what's the next step? So we want to find where the area is maximum. So we have to solve for values of x first. So we're going to make a equal to 0. Now, using all the skills of factorization and solving you've done all the time, you should be able to identify pretty quickly that when a is equal to 0, we're going to get possible solutions here of x is equal to 0 or x is equal to 20. So what we're going to do now is take these values and sketch them onto some sort of parabolic curve. So here in green I have my parabolic curve. Cross this again, because it was negative 2x, it's going to give us a maximum turning point. And it's crossing the y-axis at 0 and 20. Due to the symmetry we're aware of with our parabolic curve, we can see that this maximum turning point here, our vertex, is going to occur at x equals 10. And value of x was our width. So straight away here, the width of our garden bed is x, which we can now say is 10 meters. Substituting this value of 10 into this equation here, the length of our garden bed is going to be 20 meters. Now, the whole question was, what was the largest possible area you can get? So, area is equal to length times width. We've found those two values now, so it's 20 times 10, or 200 meters squared. So what we're saying is, if we had 40 meters of fencing, you can have a whole range of different values of your length and width, but to get the very most area from that garden bed as possible, you would have to have sides of 10 by 20. 10 meters here, 20 meters there, 10 meters there, 40 meters of fencing used for a maximum area of 200 meters squared. So again, what was the process? First of all, use information we know to develop some kind of quadratic equation. Like we've done so many times in class before, solve it when this quadratic equation is equal to 0, giving us, in this case, two sets of solutions. Using the slight sketch of the parabolic curve, we determine what is our vertex point, our turning point here, our maximum or optimal solution, which in this case was x. Use that information back into what we originally established to try and find out our optimal answer. And that is what we call quadratic optimization. Now it's your turn to practice it in class.